first thing you have to do with the instrument is find a nice spot to locate it where you have access to the back, plenty of room for the computer. You also have to have room for a chiller. The first thing you have to do is install the filter. The filter is inserted into the cup. Sure it's hand tight. What we'll do next is we have to attach the filtered assembly to the back of the unit with the 2 screws provided. The next thing you want to do is cut a piece of the black tubing so we can connect the inlets to the inlet of the instrument. You want to do this so it doesn't kink. The next thing you want to do is you want to cut a piece of the black tubing extra long because we're going to connect the instrument filter to the chiller. And then you'll feed the rest of this to the chiller. Next thing you want to do is you want to make sure the chiller gets set properly. You have a switch, you want to make sure it is set at 0. You then want to plug the pump into the condenser unit. The next thing you have to make sure is the plug is located correctly. The plug goes on the right side of the instrument. So what you have to do is you have to take the plug out, and it uses, unfortunately, a metric wrench. 13 millimeter. You want to remove this and place it in the right side. The next step is we have to put a couple of pieces on the back of the instrument. It's LECO part number 621604 and LECO part number 621605545. That's so we can tie the water line into the feed line of the pump. On this piece that I'm turning in now, you have to put Teflon tape on it. Make sure you get a nice tight seal. For this part of the installation, you'll need a 1/2 inch and a 9/16 inch wrench. Next thing you want to do is you want to take your feed line to the instrument and plug it into the feed line of the pump. Insert it firmly in and pull back to make sure it is firmly attached. Next thing we're going to do is we're going to cut the drain line to length. The length has to be as close to a straight line as possible to the chiller. You don't want any kinks in the hose or any loops for the drain return line because you don't want the water to hang up. You want it to go straight to the chiller. What you'll then do is plug the drain line into the back of the instrument. The next thing you want to install the drain line through the cover. You want to go through approximately anywhere from a 1/2 inch to an inch in through the cover, and then put the cover on top of the machine. The next thing you want to do is attach the power cord to the instrument. The instrument has the capability of using either 115 or 230 volts. It is an auto switching transformer in it. Plug in firmly and then tighten the hold down screw. Next thing you want to do is you want to plug in both the chiller power line and the instrument power line. Next thing you want to do is you want to assemble the computer package. Make sure that you connect the mouse, the keyboard, the monitor to the back of the instrument. After assembling the computer with the keyboard, mouse, and monitor, you want to connect the Ethernet line from the computer, which is into the bottom Ethernet card, into the back of the instrument. Next thing you want to do is you want to connect the pneumatic line. Your pneumatic pressure should be set at 12 psi. The next step we're going to do is we're going to attach the O2 oxygen line supply to the back of the instrument. This is going to be pressurized to 450 psi, so you want to make sure that everything is nice and tightly connected. The next thing you want to do is you want to attach the combustion vessel oxygen fill line to the back of the instrument. Once again, remember that this is going to be pressurized to 450 psi, and you want to make sure that the connection is nice and solid. Next thing you want to do is attach the DS9 cable to the back of the instrument. This is the control switch for the combustion fill vessel and what controls it to the 450 psi that will be used to fill the vessel. Next thing you want to do is connect the oxygen line to the regulator. Once again, making sure that firm connection and it's nice and tight so you don't have any leaks. To be at 450 psi. Next thing you do is you attach the regulator to your oxygen bottle. You want to use ultra high purity 99.99% oxygen. You then adjust the regulator up to 450 psi. If you have the optional wash station, you would connect the DS9 connector and the O2 out in a similar manner that you would if you didn't have it. It does have its own connectors, and it also has a vent line which you can vent either to a fume hood or a wash bottle. Plug in the power cord, attach it to facilities power. You will receive a dongle with this. It's the registration key. You'll also must make sure that that is plugged into the back of the instrument. That's to register the software. You also must make sure that the Ethernet cable is plugged in to the bottom Ethernet card. This is the control card for the instrument. The next thing you want to do is you want to fill the chiller reservoir with distilled water. Please use distilled water. It's what we recommend for the unit. Do not use RO. Do not use DI. Do not use tap. Distilled water only. You want to fill this till it's about an inch below the level of the lid. The next thing you want to do is you want to start up the computer. Do not open the software. Power up the instrument and then power up the chiller. On the chiller you have to turn on the circulator and the chiller both. When you turn on the chiller you have to first turn on the switch. Then you will press the little arrow key here. What you will do then is you can set the temperature up and down. You should set the temperature to approximately 15 degrees. Your chiller is now on and ready to go. After we've set the chiller temperature, we want to open the AC Wind software. When you open the AC Wind software, let it step through the progression of configuring the network, pulling the devices. The instrument is then going to lower the head and bring it back up. The bucket will then fill with water. This process is a fairly slow step, so please allow time for it to complete this important step. It's important for this step to take place because it sets all the set heights for the mast and everything else and confirms with the firmware that all these settings are correct. Slip. The filter used to have bolter screws, hex heads. After it completes this step, the bucket will then fill with water. One thing to remember is to make sure that your chiller is kept full of water at this time. You'll have to frequently refill the chiller because the water that's in the chiller will be pumped over to the unit. One of the things you have to check on is after the bucket fills is look inside and inspect for bubbles forming on the baffle and the inside of the bucket. If you do have that, you have to reach in, remove the baffle, take a soft brush and wipe all the bubbles off. What happens with the bubbles is that it interferes with the thermodynamic properties and could give you erroneous readings. Once that is completed, you put the baffle back in place. After you're sure that there's no bubbles present on the inside of the baffle, you want to go to your diagnostic screen, open solenoids and switches, and you want to increase the stir speed. Make sure that you increase and you start to form a vortex on the inside of the bucket. If the unit increases in speed and you get the vortex formed, you want to set it to stir slow and let the system equilibrate. After the system is stabilized some, you want to go into the system page under configuration and set the temperature. The water temperature should be set 3 to 4 degrees above the ambient temperature. You will have to allow the instrument, once again, to stabilize out some, and then you can set the duty cycle. To set the duty cycle, you have to go into the maintenance tab, and you will see a flow adjustment. You'll let that screen come up. You'll press next on the screen, and what it does, it will give you a series of instructions to follow. It will tell you whether to rotate the flow adjust needle clockwise or counterclockwise. You're trying to reach a target of 0. If it's red, you're too high with your duty cycle. If it's black, you're too low. How you adjust your duty cycle is by adjusting the flow. You have a flow controller on the back of the instrument. So in order to adjust that, either way, you follow the instructions that are given by the computer to see that you have adjusted the duty cycle appropriately to get down close to 0. And how you can check the stabilization is go to your diagnostic screen on their chart and make sure your temperatures appear to be stable. If they're nice and stable, you're ready to proceed with running an analysis. What you would like to do first is run several benzoic acids to do a calibration. Under the name, you would log in your sample name, you'd weigh up your sample, enter the mass, and choose the method. You have 2 methods available to choose. One is a true speed, which is a recommended method, and the other method is delta T. You can also design your own methods, but we have found that the true speed is a very adequate method to be using. You want to make sure your fuse length is set at 10. You're now prepared to run an analysis. This is prepare the igniter wire. You want to find the approximate halfway point and twist the wire in half. The objective here is to try and make a small loop while twisting it in half. This is going to be kind of difficult to do and show on tape. What you want to do is you want to make a loop and pull it tight to the igniter. You want to leave a small loop where you can attach the igniter string to. You also want to make sure that the wire, when you make this loop, does not touch, because that would be a sight for it to ground. Okay? To get your loop made, straighten it out. You look at it very carefully, make sure it's not touching the other wire. You've successfully made your ignition wire loop. What you have to do next is remove the old ignition wire. You'll need 2 5/16 inch wrenches. On each side, loosen the screws. The shorter electrode you may want to carefully inspect. That electrode may need to be replaced at the same time as the igniter wire, depending on the condition of the electrode. What you want to do next is carefully put the new wire in place. You want to try as much as possible to make sure that loop that you made is pointing up at you, because you want that when you hang your string from it, you want it to be pointing in the down position. You may need to use like a pair of needle nose pliers to maybe hold it in place till you can get it tightened. You may have to actually ask somebody to help you do this while we attempt to get everything back in place. You then want to tighten the bolts to make sure it's tight. You've replaced the ignition wire. You can probably slightly bend it too to make sure it's in the center position and pointing downward. The next thing we want to do after we replace the igniter wire is do a life test. Place the ignition system back in the unit. What we have to do next is we have to go to the solenoids and switches page, hit Control-Shift-L. We can set how many cycles we want to life test the fuse. Hit life test and it's going to go and life test the fuse. You should see the fuse glowing red. If not, you may have to replace the nuts and the short connector right there. One of the things to remember during sample preparation is you have to prep the crucible. When you prep the crucible, you have to take the new one and put it in the oven at 500 degrees C for 4 hours. After you run an analysis, you want to make sure the crucible is clean, and it may help to either put it in the oven again or just run a Bunsen burner flame into the crucible to make sure there's no leftover hydrocarbons. What we want to do next is attach the igniter string. What you do is you take the igniter string, hook it through the loop, pull it down, and give it a few twists. This attaches the ignition string to the wire. What you want to do next is you want to put the sample capsule in place. Take the igniter string and make sure the sample is placed on top of the igniter string. You're now ready to put the sample igniter into the combustion vessel. Carefully remove it from the station and place it carefully on the vessel. You don't want to push the igniter down into the vessel because you don't want to nick the O-ring. Nicking the O-ring would be a source of leaks. Hand tighten the ring on the vessel. When you put it on the fill station, use one hand to steady it, and then let it freely hang, and then tighten down the flow control valve. After that's in place, you want to press the button to fill the vessel. When the vessel is done filling, you will hear a pressure release on the backside of the instrument. This will indicate that the vessel is filled. The next thing you want to do is disconnect the vessel, slide it out, and put it in a container of water. Let it sit for a few seconds and watch to see if you have any bubbles forming. This is our leak check, and we want to make sure that we don't have a huge amount of bubbles coming out of the vessel. We can now place the vessel onto the load head, slide back, and let it hang freely. Make sure you slide the vessel all the way back. You then want to press once the green button on the instrument. What it's going to do now, it's going to lower the vessel in to a certain point and do a check on temperatures. Then it's going to lower it the rest of the way, inflate the bladder to seal the bucket, and we'll do the ignition and fire the sample. The equilibration time for this is approximately 70 to 80 seconds. Then it will ignite the string to ignite the sample and run the analysis. The alarm will sound twice when it's about to fire. A couple things to watch for is to make sure about 6 to 7 seconds in the actual analysis time that you see that the vessel has fired. When the analysis is finished, the lift mechanism will bring the bucket back out of the water, and you're ready to place the next combustion vessel in place to run the next analysis. What you'd like to do under standard operating conditions is run several benzoic acids, calibrate the unit, then proceed to run your samples. Approximately every 10 to 15 samples you may want to run a benzoic acid to make sure that everything is running correctly as a quality check. After your several benzoic acid samples have completed running, you want to calibrate the instrument. What you do is select the samples you want to use, go to calibration, and highlight calibration. This now calibrates the instrument. So you're ready to run your sample analysis. After the vessel has been thoroughly vented, you want to unscrew the vent plug all the way. Then carefully slide the combustion vessel off. Loosen the seal ring. Use the igniter removal tool and carefully remove the igniter. Next, you want to take the crucible out and thoroughly clean it and rinse it. Clean it with a wire brush to make sure there's no debris left and rinse it thoroughly. The igniter you want to inspect to make sure nothing is broken as far as the wire, and also rinse it off with water. Depending on if you're going to analyze the residue, you're going to rinse out the inside of the vessel thoroughly. If not, analyzing the residue, you want to thoroughly rinse out the vessel for the next use.